We have a rule, if there is an accident, the three of us cannot be together, so. So, welcome everybody. Thanks for coming. So, my talk today is this strange title, How Much Does It Cost? All the time we are getting proposals of new features. This is just a short list of some proposals we got in last 3 months or maybe 6 months. I'm not sure. Most of them are from the last month. I mean, and you get all kinds of proposals of things to change in Lua, things to add, mostly things to add in Lua. We have this alternative way for string format. In Lua, we have a function to format strings that is more or less like printf in C, and there was a proposal to make it more like C++, that marvelous way that you can connect a lot of operators and send things to standard in and send stuff to standard out. There was a proposal for a scanner that is UTF-8 aware, not exactly aware, but more UTF-8 acceptor or anything like that. There was a proposal for a new syntax with a colon dot, a new pattern %b, big B. There is a pattern in Lua for pattern matching. There is a small b that matches pairs of parentheses or anything correctly nested, and this does exactly the same thing, but it captures what it matches without the quotes, without the extra parentheses or anything like that. There was a proposal to use a method, something called name when converting something to string. There was that proposal of adding square brackets to create new tables. We already in Lua, we can create tables using curly brackets, but this guy prefers square brackets, so he proposed why not also allow square brackets to do exactly the same thing that curly brackets do. And there was a proposal for a new array type. For table, these two are new array type, and table as fallback for tables comes more or less every 6 months, at least someone proposes something like that. There was a proposal for a key meta method to allow hashing, to change the way things are hashed in a hash table, so you can consider different stuff to be equal for hashing purposes. Also, this one is something that light syntax for anonymous function. This is also something that comes more or less every 6 months, but each time with a different syntax, but all the time people are proposing something like that. Here is an example of one of those proposals. This is what we could do with a UTF-8 aware scanner. This is a correct program. It runs correctly. And you can see that it greatly improves readability. You have function, function, function. If function is 0, then return none, else return function times function of function -1. And then you have comma function 10, and everything works correctly. This is just, and it's a very, very simple change in Lua. It took me like 2 minutes to implement this feature. Actually, it was really fast, really easy. So the question we have is, what is the cost of a new feature in a programming language? Why we refuse some features, why we accept some features, what more or less we consider when we think about adding a new feature in a programming language. So in the talk, I'll talk a little about some criteria we use for this judgment and a few examples of the costs of some features already in the language. I will discuss only features that are in the language because, as you see, one of the difficulties is exactly to understand some costs. Some costs, sometimes you don't see it at the time, only later you realize how much you are paying to have that feature in the language. And so I preferred in this talk to consider only features that we have had enough time to understand what's the consequences. So this is just an illustration. Please ignore this code. So of course, the one main cost, the one that most people think about when proposing a new feature is lines of code, or more generically, the implementation effort you need to implement the feature. And a lot of times people propose and exactly say, why not? It's so easy. It's just 3 lines of code or 10 lines of code or whatever. It doesn't cost. I mean, that's the main cost people think about adding features. It's just, oh, okay, I know how to implement that. It's just this, that, and that. So it's cheap. Why not to add it? For instance, why not to add square brackets to create tables? It's very, very easy to implement that. It's just 2 lines of code, and one more user would be happy because he could use square brackets instead of curly brackets. And of course, it is relevant. I'm not saying it is not relevant. It's a very relevant cost, but of course, it's not the only one we have to think about. Of course, another cost we have to consider is performance. We have to consider how much it helps, how much it improves the performance of people using that feature. I mean, can we implement that feature in really more efficient ways than the result if you do the same functionality without that feature? And of course, also we have to ask whether it impairs the cost of all programs that don't use that feature. In particular, for interpreted languages, this is very important. For compilers, it is a little easier. I mean, usually the cost is in the compiler, but it's not that difficult to avoid costs in the generated code, although some features do have costs even in the generated code. But in an interpreted language, almost any feature can cost for the complexity of the interpreter, and then it will cost for the whole code being run by the interpreter. And some features, even when you don't use that feature, you are paying some price, sometimes a very little price, but it's a price everybody pays for a few people that need that stuff. Documentation is also a very important cost. So we have to ask whether it's hard to explain the feature. It may sound the same point, but it's quite different whether it's hard to explain and whether it's hard to understand. I'll give an example. So we have to ask whether it's hard to explain, whether it's hard to understand, whether it's hard to guess. Nowadays, few people read the documentation, so the kind of implicit documentation, the culture around the feature, what people you find when they search for that feature in the internet. So people that trying to explain the feature really understands what it does, or there is a lot of wrong explanations in the web. Also, it's not in here, but it's how easy it is to explain the feature without referring to the implementation. Sometimes people mostly people that think about, oh, it's easy to implement, and then, oh, how does this work? Oh, it's very easy. When that function is called, it tests whether that bit is set or is not set, and then it does that, and they say, oh, it's completely explained. You know exactly what the code does, but it's very hard for programmers to abstract that to the language level and understand how they can use that in their programs, how different situations will react with that feature in specific scenarios. Another question that this is quite abstract is what we call conceptual integrity. That is how the feature fits with other features. It's similar to other features. It has the same similar limitations or it has similar allowances, and also whether it follows general. I mean here general principles is not general in the civilizations general, but inside Lua, I mean the principles that we adopt in the language, does the feature fits with what we think about the language, how people think about the language, or how people understand what the language is about. Also, another very important point is generality. How general is that feature? A lot of people propose something because I need exactly that, and then because I need to do that, so I want a feature. Oh, you have to have a factorial function in your library because I need to compute factorials. And then, but then you ask, but does it solve all problems, related problems? Does it solve unrelated problems? I mean, is this feature useful for other things? It's easy to adapt, it's easy to change a little, so you can, or it is something very, very, very specific for a very, very unique situation. So sometimes it's very difficult to measure that. Another point that we consider that a lot of people do not is testing, how easy it is to test a feature. Sometimes you see a feature and say, oh, that's not difficult, that difficult to implement, it's not that difficult to explain. It can be useful, but sometimes I, in particular, gets like nightmares thinking how I'm going to ensure it is working correctly. This is, there is one particular example we'll see later that has this problem. So the first point is whether it's easy to test. Once you test, if you find a bug, how long does it take to debug the feature? Because that's also cost, implementation costs you have, even if a few lines of code sometimes, oh, it's just 10 lines of code and then an extra week debugging that 10 lines of code. And then you change anything 6 months later, and then one more week redebugging that 10 lines of code because it interacts with everything in your program or anything like that. And whether, that's a strange question, but of course it's important, whether bugs can be severe, I mean how problematic it is if the feature has a bug, how the bug can be bad for users. And this is also one of the most difficult things to evaluate, and also one of the reasons why we are so conservative when considering new features, is how easy it is for a feature to be an obstacle to evolution of the language. That happened several times along the evolution of Lua. We add a feature, think, oh, this is exactly, oh, it's so cheap, it's so easy, it's just an extra syntax for something or just some, and then 2 years later, 3 years later, or a long time later, we decide, oh, we have this perfect feature we have to have in the language, except that it's impossible to implement because of that other feature. In the past, we solved those problems by removing the old feature. Now we are more, the language is much more stable, it's much more difficult to, from time to time, we still remove stuff from the language, but we do not have the same freedom we had in the early versions of the language. And we'll see here too, several cases of how things interfere with one with the other, and mainly, as I said, with future features, how features interfere with the future. Or say, oh, let's put that in the language. Oh, no, it's impossible because of some decision, some square brackets we allowed it like 3 years ago. And of course, related to that is whether the feature restrict the alternative implementations. Again, this is related. A lot of people say it's so easy to implement, and they consider how the code is today and say, oh, Lua already has all the mechanisms to do some stuff, and then you just add something in that mechanism and the feature just appears out of nothing, and it's so really easy to implement. And then we decide, oh, let's change completely the implementation of something in Lua, and it's, oh, okay, we can do all that, except that it will be impossible to keep that particular feature because that feature cannot be supported with this. So each feature we have restrict our choice, our implementation space, what options we have to implement the language. So let's see now a few case studies, see how we can apply those criteria to some features we already have in Lua, and see how exactly what price we have to pay for them. This is a very, very old example in Lua, but shows how things interact. In the very first version of Lua, in both Lua 1.0 and 1.1, we used a single equal sign for comparisons. And we didn't have any ambiguity because the syntax of Lua ensures that we knew whether we are looking for an expression and then A equals B would be a comparison, or whether we were looking for an assignment and then A equals B would be, I mean, for a statement, and then A equals B would be an assignment. And so what's nice at that time, a lot of it was not as common as is today to use a double equal signs for comparison. And so we thought, oh, that's good. Let's keep the Pascal, and I don't think Fortran used that, but it's several other languages used a single equal sign. And so what's nice, because the Lua has a very restrict and small syntax, it was very easy to distinguish, as I said, so we put that in the language. In particular, in Lua 1.1, both 1.0 and 1.1, we have different syntax for records. That is, here we are creating a record with a field that gets the B value. And here we have an array with a Boolean here, whether true or false, depending whether A is equal B or not. And then in Lua 2, we decided to unify both constructs, and we got the constructors we still have today of a single curly brackets. And then we got an ambiguity here. So if we couldn't change that, we would be blocked to do this unification. As I said, at that time, we had the freedom to just change the language. And okay, equality now is 2 equal signs, but if we didn't want to change that feature, we would be blocked to do something in table creation that seems completely unrelated to equality. How is the equality operator? Here's a very simple example. Comments of double hyphens in Lua. It's common in several other languages. Haskell used that comment. Eiffel also use this style of comments. But it has a problem that it precludes us to put a decrement operator C style in Lua. You cannot write A minus minus because minus minus is a comment and then. So from sometimes this is good, I mean, because this is something that people do not propose because they know, I mean, most people, or when they propose, we have a very quick answer. It's impossible, so it's out of the question, and so people do not insist. But it is a kind of cost. We decided, oh, it would be good for Lua to have, and of course, because of conceptual integrity, it would be strange to have plus plus and not to have minus minus, so it mostly precludes also the increment operator. And of course, it also precludes a new language, Lua++, because again, for conceptual integrity, it would be strange to have a Lua++ without plus in the language. Another problem with comments, I don't remember which version, we introduced comments with a syntax was actually what that was for strings, but also comments also was double hyphen and then double square brackets. And we thought, oh, it's in the syntax of Lua, it's impossible to appear double square brackets. So this is safe to use as comments in general, but we forgot that it's easy. It's impossible to appear open square brackets, but it's very easy to appear double closing square brackets, like in double indexing of arrays, and that's very common operation in some kinds of code. And of course, if you try to put that kind of code inside comments, you have problems. And then that's what's one of the motivations to add the equal signs later for comments. That was not difficult to fix, but it could become difficult to fix. Multiple returns is a feature with several hidden costs. It's at one hand, it's a very powerful concept. It's fundamental for what I call generic call mechanism. When you write something like f as a parameter table unpack of a table T, you can call any function you want because f is a variable that can refer to any function in your code, and the unpack can pass to that function any number of parameters with any kind of type. So with this single line, we have something that we don't have in C, for instance. Is something in C you can have a variable parameters, but you cannot call. You don't have variable calls. I mean, you cannot in a single statement call functions with a variable number of. I mean, call a function that may have. You can be calling it with three parameters or 4 parameters or anything like that. So at one hand, it's a very powerful mechanism. On the other hand, it has several small problems, or not that small problems. One problem is the conceptual integrity, because we have a kind of a second-class data structure, the things being returned. It's hidden inside the language. We'll see when we will discuss Varargs, variable function with variable number of arguments. Later we'll see this can become kind of a big problem. For instance, this problem of second-class data structures, nils become much more significant than we intended. I think in the beginning of Lua, you always think, oh, nil is something that you can mostly ignore. But in a function returning that can return 1 argument or 2 arguments, sometimes it can be a difference whether a function returns nothing or returns nil. And sometimes it can be even the difference whether a function returns 1 nil or returns 2 nils. And of course, I always think that was a bad decision. Functions can return nils followed by something like in error messages. And it's kind of, if new is nothing, it's kind of saying there is nothing, and then after nothing, there is something important. And in tables, exactly, this is something that you should not do, and people kind of learn not to do, but with multiple returns, kind of the language almost impose you to do that. Also, multiple returns puts a lot of restrictions on the how we can implement the language. For instance, because of multiple returns, the stack frame of a function does not have a fixed size. I mean, the space you need to execute a function. This is a very important concept in implementation of programming language. Usually you call a function, and then you allocate in the stack the space the function needs to work. But because that function can call other functions, and those other functions can return a variable number of results, the calling function has no way to know in advance how much space it will need to keep all the results from any function that it calls. So this is kind of complicates a lot the implementation of the language. And in particular, it complicates a lot if we try to implement the language, for instance, translating the code to other languages or to other virtual machines, not the Lua one. Also, this may be a very small detail, but in the C API, all functions in the C API return an integer, and they have to return this integer only because functions have a variable number of returns. As I said, when we translate to other language, to other virtual machines, we cannot use the native, the primitive way of returning because almost all virtual machines around return either one fixed return or at most a 0 or 1 return. And we do have a very small, but not zero, cost, even when a lot of people don't use multiple returns. Most functions return nothing or one result. But, as I said, because this is a dynamic language, every single return, every single pair call return must check whether the function is returning more than one result and adjust the stack, adjust what it needs to be adjusted for all calls. As I said, this is a very small cost, just a test, a check in the code, but it's something that everybody pays all the time, even when not using multiple returns. Varargs, that's in particular the new style of Varargs that you can use you can declare in the function arguments ending the list with 3 dots, and these 3 dots kind of magically captures all extra parameters, extra arguments that you give to a particular function, and inside the function you can use these 3 dots expression to get all those values that were captured when the function was called. Again, this is a very big problem of conceptual integrity. In the old style, we had something that it's much simpler, that we just collect all extra arguments in the table, and so you could use the table inside the function. Table is, as I said, is a regular data structure in Lua. With this new design, we have kind of second-class data structure, and sometimes it is a little more efficient than tables. In particular, you don't have to do dynamic allocation because it lives in the stack. On the other hand, exactly because it lives on the stack, it's very limited what you can do with that kind of expression with a Vararg. There is a lot of proposals all the time. Why can't we do that with Varargs and trying to increase the number of operations, number of tricks we can do on top of Varargs, because it is a little more efficient. And also it demonizes table creation. I mean, it's kind of the language itself recognizing, okay, tables are not that efficient, don't use tables, we have something instead of tables for use to use. So the language itself, it's kind of recognizing, don't use tables. That's not a very good message to pass to users. I mean, the table is the main thing in Lua. If you want, you can try to, a JIT compiler could optimize that, but the language itself should not avoid using its own structures for what it should. It seems a good fit. And of course, it's also some small cost, even when people not use. Again, we have to, all functions, because of the smart way we have to implement. Again, Vararg has a very particular implementation in Lua that's very smart trick, but the way the trick works, all functions pay a very small price, but it is a non-zero price. Even, I mean, all functions, I mean, even non-Vararg functions pay a small price in every call because of this mechanism. And again, most functions in Lua are not Vararg. Vararg is something usually that you use for not exceptional case, but some kind of special cases. It's not something you use in regular code. It's not something people commonly use in critical performance code. So this maybe was not a very good idea. The incremental garbage collector is a very good example of problems in testing. It has almost zero cost in documentation. I mean, documentation, you just mention, okay, Lua has an incremental garbage collector, but it has no part, almost, except of course for performance, but performance is always something that you have to measure anyway. But except for that, it is mostly invisible to users. Most people use Lua, and it makes no difference at all whether it is using an incremental garbage collector or a stop-the-world collector. But it has very, very high costs in testing. I mean, test an incremental garbage collector, as the name says, for those that don't know, is a garbage collector that collects memory that are not being used by the program anymore at the same time that the program is running. So the program runs a little, allocates some memory, and then, for instance, every time the program allocates 10K bytes of memory, then it calls the collector runs a little, and then traverses like 3 tables or 4 tables, and then returns to the program executes a little more, and so you don't have to stop the program for long to doing a complete collection of all your data from time to time. But because of this interaction between what we call the mutator is the name people from garbage collection gives to the program. I mean, for people working with garbage collection, the program is just an annoying thing that is just changing your data while you try to collect things. I mean, the only important thing in the program is to collect garbage, and there is some extra stuff that you don't know why it's there, just annoying you. So they call it the mutator. And of course, the interaction between the mutator and the collector is mostly unpredictable, because every 10K bytes of memory, it can happen almost any time. And if you change just very, very small things in a program, it changes the amount of memory the program is using at any given time. And so it changes when it's going to call the collector as the program executes. And because the collector does small steps, it makes a lot of difference what steps it is doing at each particular time. So it's a nightmare to test that, because sometimes when there is a bug, as I said, it's to debug that is even a worse nightmare, because as I say, this is typical, you just change the name of the program instead of Lua. Okay, now the program is called Lua 1 instead of Lua. But you have in the name of the program isn't a parameter in the arguments, the Lua gets the arguments. So you have a string with 1 extra byte. And so that changes, this is enough to change all calls to the garbage collector as the program runs, this extra byte, and then the bug disappears. So, okay, Lua has a bug, now I will rename it to Lua 1 to test it separately, but now Lua 1 doesn't have the bug, or it doesn't show the bug, you cannot find the bug anymore. So it's a complete, and of course, when you are able to reproduce the bug, all you know is the obvious thing. Okay, the program is assessing something at one point that seems completely normal. It's just trying to get the value in a table. And even if you use a good tool like Varargs or any tool that shows you all problems in allocation, what it shows is, okay, this table was freed. What's the past of freed? I don't know. Freed? Thanks. Well, it was released by the garbage collector some time ago. Completely, I mean, there's nothing wrong. Everything seems correct. The table was released, and now someone is trying to use the table. What is wrong? Anything in the logic of the garbage collector. I mean, the problem is because the table was released because it was not marked, not because it was marked, but because it was not marked. So how do you find why the table was it's no use to try to find when the table, I mean, when the table was released, it's very easy. It's always at the same time. You release everything that is left that the program is not using. But why the table was not marked, it's so every time there is a bug in the garbage collector, hopefully there is very few bugs currently, but when there is a bug there, it's just like, how can I debug that? And then just stop, forget about it for some time, go for shopping, go for drinking, go to do anything else, and then you come back a few days later and okay, now I have to spend at least 2 days trying to do all tricks we have in your debug toolbox to try to find that kind of bugs. Something that is very important to very powerful in Lua, that finalizers and weak tables. They are particularly important in Lua because of the integration between Lua and C, and so we use a lot that weak tables is the equivalent of weak references in Lua. It's a way to keep a reference to an object without preventing it from being collected by the garbage collector. Finalizers is a function that you call when the object is about to be collected, and sometimes, for instance, you have some resources in C that you have to release when the object is collected, so finalizer, it's very important, and weak tables are very important because sometimes it's the reverse. In C, you have something that refers to an object in Lua, but the C part is a kind of proxy or a correspondent to, okay, is a kind of correspondent to the Lua object, and so you don't want to prevent the Lua object of being collected because it has some C part referring to it. So they are key ingredients in Lua, but they, of course, they have a very big impact on alternative implementations. For instance, now there is a lot of virtual machines that offer you as an advantage, oh, this virtual machine has already a garbage collector, so you don't have to implement the garbage collector, but hardly this garbage collector will have exactly the same semantics of the original garbage collector. For instance, a lot of garbage collectors do not support weak references. Some of them support finalizers, but not with the same guarantees that Lua gives to finalizers, the order of execution, or even whether they will be executed. And of course, there are some extra costs for the garbage collectors to support that. Thankfully, those costs in our implementation is mainly when you use those features, but it is some extra cost. But this here can be a big problem. It's very common. Oh, now let's implement Lua on top of JavaScript, or on top of Java, or on top of any language that does have garbage collection, and it's quite complicated to replicate those stuff on top of a different collector. Well, we have the length operator. This is a very good example of a feature that is very easy to explain, and it's very difficult to understand. The explanation is just simple, we can do it mathematically. It's just say, oh, this, that, but people, I don't know, people expect something different. People do not believe in the documentation, or people do not understand because it's difficult sometimes. Or, as I said, most people don't even read the documentation. But I think the main problems are people do not read documentation, and when they read, they kind of do not believe. They just expect something, and so they read the documentation, say, I don't care. I know what it does. The documentation is just some noise there. And it's a big problem also with conceptual integrity, because as I said, if we consider that it's correct for functions to return nils, like error codes in Lua, if you have anything like that, this is a typical example, you want to collect all results from a function. Oh, that's very easy, just do that, you collect all results from a function in the table, but then if the function is returning some error plus a message, error message, then you should not use the length operator. How is my time? I still have some. 1 minute? Yeah, are you sure? So I skip this. Well, just to finish, just coroutines is something that is very, very hard, difficult to measure cost in the implementation. It's something strange. The coroutine itself, it's not difficult to implement, but it demands that a lot of other parts of the implementation follow some rules so that coroutines work correctly. So it has a high cost in implementation, even if you say, oh, I'm going to remove coroutines. You can just, remove just this few lines of code. But then you can, there is no more coroutines. Then I can change the whole implementation of the language, because without coroutines, I could implement it in a completely different way. The main problem is exactly that you cannot use the C stack, because anytime you can jump and just destroy the C stack to change for a different coroutine. And it has some very strange interactions between coroutines, the garbage collection and closures, because sometimes you are inside a closure and you think, oh, that function, that variable is still alive because it's in the stack, but then that stack becomes garbage, and so suddenly something that the function never returned, but the variable became garbage anyway, because the thread that was running that function just disappeared from your program. And it's very hard to test, because exactly almost anywhere you can call something that can yield, can suspend your thread, and then can happen almost anywhere in your program, and you have very strange interactions between different parts of the program. Oh, I skip that part. So, some final remarks. Many applications can reap big benefits from small and simple additions to a language. That's why we got a lot of requests. But each application needs different small and simple additions. So there is no simple one addition that you can do and do a lot of people happy. As I said, it's very hard to foresee all consequences of a new feature. Some features only many years later, when we decide to change something in the language, that we realize that we cannot do that, or that it's much more difficult because of something that we decided many years ago. Another very important point is that if you want to avoid bloating the language, features should not be considered by themselves. All features are good, or most features are good, but you have to measure them against other features, because you are not going to add everything. So even if, okay, this is good, it's just a few more lines of code, this is also good, it's just a few more lines of code, and if you add all that stuff, it's not a few lines of code anymore, and it's not a few lines of documentation anymore, everything becomes bloated. And finally, when we consider a new feature, we can err both by adding a bad feature or by blocking a good feature, a good one. But one of these errors is much easier to fix than the other. So it's easier to figure out what is easier to fix it later. So that is what I have to talk today. Thanks.
Any questions?
How much time in the development of a language can you afford? Can you afford to stay malleable? Like you, after the first version, you're still saying some things are going to change.
So the question is, how long can we stay flexible in the design of a language? I think depends a lot, but mainly I think it depends on how is the adoption of your language. I mean, it depends how many people are using the language, who are using your language. So usually you just release the language and you are using the language. So if 6 months later only your group is using the language, it's very easy to change that. If a lot of people are using that, it becomes more difficult to change. All languages change a lot. Some, for instance, C, for instance, now cannot afford to do a change that is incompatible. Even it does sometimes, but it's incompatible with some weird cases that people do not even realize. But I think the main question is your user base.
Hi, and I saw Lua, the good language that a lot of softwares implemented embedded systems with Lua, a lot of Regis and Nginx, and a lot of softwares. And what are the few and the freshest and when the first softwares implemented the Lua interface? And what's your feelings? And oh, my software was developed around the world, and Lua is a programming language founded in Brazil. Brazilians are proud to Lua to be successfully, And what are you feeling?
I'm proud too. It's a good feeling. It's a very good feeling.
Some time ago, in the Lua user group in Brazil, you said about using Lua for functional programming and not recommending it so much. Can you very slightly say something about that? Use of Lua for functional programming.
Well, the point is just that Lua has a lot of things. I mean, it has functions correctly implemented as functions at first-class values with flexible scoping and anonymous functions, etc. Now, that's not so exclusive of Lua, but for a long time, it's, I mean, for imperative, most imperative language did not have that. There are now, and Lua has had that for a long time. And so it's a, I mean, it's a good paradigm programming paradigm that you can use in Lua. It's a good, I mean, it's not a, if you really want to do functional programming, you should use a functional language. But I mean, inside Lua, there is a lot of interesting tricks, interesting techniques that you can use, that you can kind of import from functional programming and use in Lua programs. I do that a lot. So that was the last question, right? So again, thanks.